so that we can have this on the record. Over to you, Sally.
All right, so thank you very much for having me. I'm really thrilled to be here today to talk about the centre that I run called Data Analytics for Resources and Environment. It's an ARC industry transformational training centre, which means we train PhDs and postdocs in data science. Now, with applications to natural resources. So we like to think of it as it's a very rigorous mathematical PhD, but always the projects are motivated by problems that we find in natural resources, and they are applied to those problems. So we use the complex natural resource environment, in fact, to be an incubator for thinking about new data science ideas. So rather than coming up with methodology and thinking about where we're going to apply it, we start with the problem and think about what's missing to really answer this complicated problem. And to do that well, you also have to work with people outside data science. So we are not going to we are not specialists, or I'm not, so the data scientists are not specialists in natural resources. So the centre is equally split between data scientists, which I've listed on that side there, and the domain scientists. So there's this idea that, data alone is not enough. And it's very much important in the natural resources. This is not, actually these are small data problems, they're not big data problems, and they're problems where there's a huge amount of uncertainty. So actually the focus is to work with the domain scientists to see what techniques we can come up with, which better actually not only give them better predictive distributions, but also a deeper understanding of natural resources. And in the natural resources space, we've broken it up into one of three things, which is water, so hydrologists, biodiversity, and minerals, because no decision taken in any one of those three is taken on its own. It affects everything. So the idea is, let's bring it all together and let's try and steward Australia's natural resources in a way that's economically viable but environmentally sustainable. So they're the sorts of ideas we come back from. Now I just have to try and move forward. Right. So just to give you, I thought I'd give you, some nice shots of the centre. So we've got a whole bunch of postdoctoral fellows, and I've listed them up there. They come from very different backgrounds, as you can see. Some of them are earth scientists, some of them are statisticians, some of them are machine learning, and some of them are physicists. But they all work collectively together on multiple problems jointly. So actually that's the key, that none of these problems, there's never a single person with a solution to them, and so they work jointly. So it's a very collaborative approach. This is our first cohort base of PhD students. So it's a cohort based PhD program. We get them in, we teach them for 3 months, at the end of which they do a sort of a mini little report or a mini little paper. Obviously it's not a paper that would go to a journal after 3 months and they've only just started their PhD, but the idea is to get them into academic writing. So we've just educated 8 of them in about 2 weeks' time. We've got the next 8 coming on board, and then following year, I think there's another 7 or 8, giving us, over the life of the project, is close to 25 PhDs that we'll be educating in this way. So as I said, there is the big focus is on, probability theory from our point of view, uncertainty if you're working natural resources. So it's about, and I'm sure I don't have to explain to you just how variable our natural environment is. We've just got to look back, actually to COVID in the last 2 years, but before that to actually what was happening in New South Wales, at least, with the bushfires followed by the floods. So that's one of the big focuses of DARE, that is, it's an uncertainty focus. The second one is that, it's data alone is most definitely not enough, and I would say therefore, and also data scientists alone are not enough. So we have an approach which says, okay, we need data and we have models for data. So these are some probabilistic models for data that you might think of proposing. But then there's a whole lot of models that actually go into the domain science. So we've got models of how plate tectonics shift over time in order to help us try and find out where mineral deposits are. There's models about how landscape evolves over time. So these are often very complicated models, a lot of ODEs and PDEs, and they're very computationally intensive to solve. And so we need mathematical and computational methods in order to be able to solve these type of problems. and so there's the sort of basically the three groups that exist within the centre. And, you know, of course, because, you know, Kerry asked me to give this talk, of course, we're Bayesian. And I've just got down there at the bottom of, you know, Bayes theory and how maybe each bit contributes to it. So hang on, I'm just going to, I keep having trouble trying to move from, the students have to take some time with industry, and I've listed our partners there. These are both government departments as well as private companies like McKinsey, like Newcrest, and some philanthropic organisations, Minderoo. So we work with a wide variety of partners. These are just some of the examples of this sort of projects that we've got underway. You can see that, you know, they're basically, you know, data science. You can see, for example, you know, under minerals, novel transitions, kernels in MCMC to explore posterior distributions in trying to figure out how deep the regolith is across Australia, for example. So these are complicated problems. Students have joint supervisors from data science as well as from the domain. So just outputs. I don't know if this is actually going to work, whether I'm going to be able to link to anything here, but, you know, we have a website, here it is. And the research outputs themselves show just a huge variety of the journals that publish. So environmental modelling and software, along with JASA, along with, then we had a really good one accepted recently at the PNSA. I can't see that up there, but it's somewhere there. So these are the sorts of outlets that we're targeting. That's it. That was a really good paper, that statistical finite elements for misspecified models. I think it's really exciting that we're producing all this sort of very, very cross-disciplinary research and actually having a really good time while we're doing it. And we're having such a good time that we're actually going on to the next thing, which we've called DASH, which is Data Science for Societal Health. And so we've got a few grants in that regard, and we're sort of running it the same way as we run DARE. So thank you very much.
Sally, that's a fantastic wealth of activity and